The universe has always been a place of mystery. It stretches endlessly before us, a vast and incomprehensible expanse filled with wonders beyond imagination. And yet, despite centuries of exploration and discovery, its greatest secrets remain locked away, tantalizingly out of reach. For every question we answer, the universe offers us 1,000 more. How did it all begin? What forces shape the cosmos we see today? Are we alone in this infinite expanse, or are others out there, waiting to be discovered? These profound and awe-inspiring questions have driven humanity to push boundaries and build tools and theories that attempt to illuminate the darkness. As human beings, we are drawn to mystery. It is in our nature to wonder, ask, and seek. From the earliest stargazers who looked up at the night sky and marveled at its beauty, to the modern-day scientists peering into the depths of space with powerful telescopes, we have always been compelled to uncover the unknown. This urge is written into our DNA, a primal curiosity that has sparked every great leap in knowledge and understanding. The night sky, with its countless stars, has long been a canvas for human imagination. Ancient cultures saw gods, heroes, and stories written in the patterns of the stars. They built temples aligned with celestial movements, using the heavens as a guide for their lives. Today, while the tools of observation have grown immeasurably sophisticated, that same sense of wonder endures. The allure of the unknown. There is something deeply humbling about the unknown. It whispers to us in the quiet moments, in the stillness of a clear night, as we gaze at the stars and feel the vastness of existence pressing in. It is in these fleeting instances that we confront the immensity of the universe and the limits of our understanding, as if the cosmos itself is reminding us of our place within its boundless expanse. In these moments, we are reminded that we are part of something far greater than ourselves. The universe is not just a collection of stars and galaxies. It is a story, an unfolding narrative that began billions of years ago and continues to this day. It is a tale of unimaginable forces, of birth and destruction, of the interplay between light and shadow, energy and matter. It is a chronicle written not in words, but in the language of physics, mathematics, and the very fabric of space-time itself. But unlike any story we have ever known, this one has no clear beginning or end. It is a puzzle with missing pieces, a symphony with notes yet to be written. And while we may never uncover all its secrets, the act of seeking is itself a profound and meaningful endeavor. It is a testament to the indomitable spirit of human curiosity, the drive to learn, to explore, and to make sense of the incomprehensible. Every question we ask, every mystery we ponder, brings us closer to understanding our place in the cosmos. The search is not just about finding answers. It is about the journey, the wonder, and the awe that comes with exploring the unknown. Each discovery, no matter how small, is a step forward, a momentary triumph against the vastness of ignorance. And yet, each answer inevitably leads to more questions, expanding the horizon of what we do not know. Consider the stars themselves, pinpricks of light in the night sky, yet each one a colossal ball of burning plasma, billions of miles away. For millennia, they were simply points of light, their true nature a mystery. It was only through centuries of observation, calculation, and ingenuity that we came to understand their composition, their life cycles, and their role in the cosmic dance of creation. Even now, with all we know, the stars continue to surprise us, revealing phenomena that challenge our understanding and force us to rethink the very laws of physics. Ralph Waldo. Beyond the stars lie galaxies, clusters, and superclusters, vast structures that stretch across incomprehensible distances. The scale of these formations is staggering, each one containing billions of stars, countless planets, and perhaps even life. Yet they are but fragments of a much larger tapestry. The universe, as we know it, is expanding, carrying these galaxies ever farther apart. This revelation, brought to light by Edwin Hubble in the early 20th century, was a paradigm shift in our understanding of the cosmos. It raised profound questions. What lies beyond the observable universe? What drives this expansion? And will it ever end? Even more perplexing is the discovery that most of the universe is composed of dark matter and dark energy. Mysterious substances that we cannot see or directly detect, yet whose presence is inferred through their effects on the observable world. Together, they make up approximately 95% of the universe, leaving only 5% composed of the ordinary matter we can see and touch. Petrifying multiply. What are they? What role do they play in the grand scheme of things? These are questions that continue to baffle scientists, their answers tantalizingly out of reach. And then there is the question of life. Are we alone in this vast cosmos? It is a question that has haunted humanity for centuries. The discovery of exoplanets, planets orbiting stars beyond our solar system, has opened up new possibilities. With thousands of these planets identified and many residing in the so-called habitable zone, where liquid water could exist, the potential for life beyond Earth feels more real than ever before. Yet, despite our best efforts, we have to find definitive evidence of extraterrestrial life. The silence of the cosmos raises profound questions about the rarity of life, the conditions necessary for its emergence, and the possibility of civilizations far more advanced than our own. The search for extraterrestrial life is not merely about finding others. It is about understanding ourselves. If we were to discover even the simplest form of life elsewhere, it would transform our understanding of biology, evolution, and our place in the universe. Conversely, if the universe is devoid of life beyond Earth, that too would be a profound revelation, underscoring the uniqueness and fragility of our existence. If the universe is awakened to the superiority of its own species, recognizing its uniqueness, we are probably a true product of a long cycling arcane. Yet the mysteries of the universe are inextricably linked to the mysteries of our existence. How did life begin? What is consciousness? Why does the universe exist at all? These questions blur the line between science and philosophy, inviting us to explore not just the external cosmos, but the internal one as well. The act of seeking answers to these questions is a defining feature of humanity. It is a reflection of our insatiable curiosity and our refusal to accept ignorance as a permanent state. From the earliest civilizations that charted the movements of the stars, to the modern scientists using particle accelerators to probe the fundamental nature of reality, we have always been driven by a desire to understand. And yet there is beauty in the unknown. The mysteries of the universe, far from being sources of frustration, are sources of inspiration. They remind us that we are part of something far greater than ourselves, that we are participants in a story that is still being written. They challenge us to think bigger, to dream bolder, and to embrace the uncertainty that comes with exploration. The unknown is not an obstacle, it is an invitation. It beckons us to venture into the uncharted, to push the boundaries of what is possible. It is a call to humility, reminding us of our smallness in the grand scheme of things, but also a call to greatness, urging us to rise above our limitations and seek out the truth, no matter how elusive it may be. As we gaze at the stars, as we send probes to distant planets and study the faint echoes of the Big Bang, we are engaging in an act of profound significance. We are not just gathering data or testing hypotheses. We are participating in a timeless quest to understand the very fabric of reality. It is a journey that transcends borders, cultures, and generations, uniting humanity in a shared pursuit of knowledge. All right, and so we continue to look to the heavens, to peer into the vastness of space and time, to ask questions that may never be fully answered. for in the act of seeking, we find meaning. In the face of the unknown, we discover who we are. And in the vast, unending expanse of the universe, we are reminded of the power of curiosity, the resilience of the human spirit, and the boundless potential of the journey ahead. The biggest questions of all. As we stand at the edge of what we know, we find ourselves facing questions that challenge the very foundations of our understanding. How did the universe begin? The Big Bang Theory offers us a glimpse into the fiery birth of the cosmos, but it raises even more profound questions. What came before? Why did it happen? And could there be other universes beyond our own, existing in dimensions we cannot perceive? What is the nature of time? We experience it as a steady flow, moving relentlessly from past to future. But time, as Einstein revealed, is not what it seems. It can stretch and bend, warp and slow. And beyond the realm of relativity, at the smallest scales of reality, time behaves in ways we can barely comprehend. What is the universe made of? The stars and galaxies we see are just the beginning. Beneath the surface lies a hidden realm of dark matter and dark energy, mysterious forces that make up the vast majority of the cosmos. They shape the structure of the universe, yet remain invisible and elusive. Are they present or empty space? And perhaps the most haunting question of all, are we alone? In a universe so vast, with billions of galaxies and trillions of planets, it seems almost impossible that life exists only here on Earth. Yet we have found no trace of it. Is life a rare, precious anomaly? Or is it hiding in the far reaches of the cosmos, waiting to be found? The limits of knowledge. As we seek answers to these questions, we are reminded of the limits of our knowledge. For all our technological advancements, and for all our scientific achievements, we are still bound by the constraints of our perspective. We see the universe through the lens of human experience, through the narrow window of our senses and our tools. And while this lens has allowed us to glimpse wonders beyond imagining, it also reveals how much we do not know. The mysteries of the universe are not failures of understanding. They are the natural result of a cosmos so vast, so ancient, that it surpasses our ability to comprehend. And in this, there is a kind of beauty. The unknown is not something to fear, it is something to embrace. It is the source of our curiosity, our creativity, and our drive to explore, an invitation to wonder. As we begin this journey through the mysteries of the universe, let us take a moment to reflect on what it means to wonder. To wonder is to be human. It is to recognize the infinite and to feel a connection to it. The mysteries we will explore are not just questions, they are mirrors, reflecting our deepest hopes, fears, and aspirations. They remind us that we are part of a vast and interconnected universe, a universe that is both knowable and strange. So let us step forward with curiosity and awe. Let us embrace the unknown not as a barrier, but as an invitation. For it is in the questions we cannot answer that we find the greatest beauty and meaning. The origins of the universe. How did it all begin? The question of how the universe began is one of the most profound mysteries in all of science. To gaze at the stars is to wonder about beginnings, to ask where it all came from, how it started, and why. The story of the cosmos is written in the light of distant galaxies, in the faint whispers of energy that echo across space and time. It is a story of unimaginable violence and beauty, of chaos giving rise to order, and of questions that remain unanswered. You can look in your own backyard and find your own life. The Big Bang? A beginning? Or just the beginning of what we know? Our best understanding of the universe's origins began approximately 13.8 billion years ago with what we call the Big Bang. This was not an explosion in the traditional sense. There was no bang, and there was no pre-existing space for it to explode into. Instead, the Big Bang was the sudden expansion of space itself, a moment when time, space, matter, and energy all emerged from a single, infinitely dense point. In the first fraction of a second, the universe expanded at an unimaginable rate, a phenomenon known as cosmic inflation. Imagine a grain of sand suddenly swelling to the size of a galaxy in the blink of an eye. This brief but extraordinary period set the stage for everything that would follow. The formation of atoms, stars, galaxies, and eventually, life itself. But what caused the Big Bang? Here we find ourselves at the edge of what science can currently explain. Some theories suggest that the universe emerged from a quantum fluctuation in a vacuum, a momentary disturbance in the nothingness that gave rise to everything. Others propose that the Big Bang was not the beginning of the universe, but rather a transition, a cycle in which a previous universe collapsed and rebounded into a new one. Is it as simple as that? Surprised Marcella. The Big Bang theory provides a powerful framework for understanding the observable universe, but it leaves us with questions that remain maddeningly out of reach. What came before the Big Bang? And is before even a meaningful concept? When time itself began with this event, the fine-tuning of the universe, coincidence or design? As we study the universe, one of the most astonishing discoveries is how finely tuned its laws appear to be. From the strength of gravity to the properties of atoms, every aspect of the cosmos seems precisely calibrated to allow for the existence of stars, planets, and life. Consider this. If the force of gravity was slightly stronger, the universe might have collapsed back into itself. Shortly after the Big Bang. If it were slightly weaker, matter would have dispersed too quickly to form galaxies or stars. Similarly, the balance between matter and antimatter in the early universe was so precise that even the smallest deviation could have prevented everything we see today from coming into existence. Scientists call this the fine-tuning problem, and it raises profound questions. Why does the universe appear to be so perfectly suited for life? Is this an extraordinary coincidence, the result of countless universes with different properties, only one of which happens to support life? Or is there a deeper reason, a guiding principle, or even an intention behind the cosmos? Some theorists turn to the idea of the multiverse for answers. They propose that our universe is just one bubble among countless others, each with its unique laws of physics. In this vast cosmic landscape, it may be that our universe is simply one of the rare few where the conditions are right for life. Others see in the fine-tuning a hint of something more, a mystery that transcends science and borders on the philosophical. Whatever the answer, the precision of the universe's design continues to inspire wonder and curiosity. Cosmic inflation, the universe's first moment. Cosmic inflation is one of the most extraordinary ideas in cosmology. It describes the first fleeting moment after the Big Bang, when the universe expanded faster than the speed of light. In less than a trillionth of a second, what began as a minuscule point grew to an almost incomprehensible size. This period of inflation explains many of the features we observe in the universe today, such as its large-scale structure and its remarkable uniformity. Without inflation, the cosmos would look very different, more chaotic, less organized, and far less hospitable to life. But what drove this rapid expansion? Scientists theorize that a mysterious energy field, known as the inflation field, played a role. As this field lost energy, it triggered the inflationary phase, after which the universe settled into a slower expansion. Despite its success in explaining many observations, cosmic inflation raises new questions. What is the true nature of the inflation field? What caused it to exist in the first place? And is inflation still happening today in faraway regions of the universe beyond our reach? If inflation is eternal, as some theories suggest, it may mean that our universe is just one pocket in an ever-expanding multiverse, a single note in an infinite symphony of creation. The cosmic microwave background, the oldest light in the universe. One of the most remarkable clues about the universe's origins comes from the cosmic microwave background, CMB, a faint glow of radiation that fills the cosmos. This light is the afterglow of the Big Bang, a snapshot of the universe as it was roughly 3,800,000 years after its birth. At that time, the universe had cooled enough for atoms to form, allowing light to travel freely for the first time. The CMB is that light, stretched and cooled by billions of years of cosmic expansion. By studying the CMB, scientists have gained profound insights into the early universe. They have mapped its tiny fluctuations, which reveal the seeds of the galaxies and clusters we see today. Yet, even as it provides answers, the CMB also raises questions. Why is the CMB so uniform, with only tiny temperature variations? What caused these initial fluctuations, and why did they lead to the intricate cosmic web of galaxies and clusters we observe today? The CMB is a time capsule, a message from the dawn of the cosmos. It reminds us that the universe is not only vast, but ancient, stretching back to a time when light itself was young. What came before? The edge of understanding. As we trace the story of the universe back to its earliest moments, we inevitably confront a question that seems impossible to answer. What came before? If time and space began with the Big Bang, then the idea of before may not even make sense. Yet, human curiosity compels us to ask. Some theories suggest that the universe emerged from a quantum fluctuation, a fleeting moment of energy that gave rise to everything we see today. Others propose that the Big Bang was not the beginning, but a transition, a bounce from a previous universe that collapsed into itself. In this view, the cosmos is eternal, cycling endlessly through phases of expansion and contraction. And then there is the idea of the multiverse, a realm where countless universes bubble into existence, each with its own laws of physics and its own story to tell. If this is true, our universe is just one chapter in an infinite book, a single ripple in an endless ocean of creation. Whatever the truth may be, the origins of the universe remind us of the profound mystery at the heart of existence. It is a mystery that transcends science, philosophy, and imagination. A reminder of the beauty of not knowing and of the endless journey to understand. Dark matter and dark energy, the invisible forces shaping reality. The universe is a masterpiece of light and structure, filled with radiant galaxies, swirling nebulae, and brilliant stars. Yet beneath this breathtaking beauty lies a hidden reality, an invisible world that we cannot see, touch, or directly measure. This unseen realm accounts for 95% of everything in the cosmos. The stars and galaxies we observe, the luminous matter that defines the night sky, make up only 5% of the universe. The rest is a profound mystery, divided into two enigmatic forces, dark matter and dark energy. These two forces are not just puzzles for physicists. They are the architects of reality, shaping the universe on every scale. And yet, for all their importance, they remain among the greatest unsolved mysteries in science. Dark matter, the hidden skeleton of the universe. Dark matter is aptly named. It does not emit, absorb, or reflect light, making it completely invisible. Yet its presence is undeniable. It reveals itself through its gravitational effects, shaping the motion of galaxies and the structure of the universe itself. In the 1930s, Swiss astronomer Fritz Zwicky made a startling discovery. Observing the Coma galaxy cluster, he found that the galaxies within it were moving far too quickly to be held together by visible matter alone. There had to be something else, an unseen mass exerting gravitational pull. Decades later, this mystery deepened. Astronomer Vera Rubin, studying the rotation of galaxies, found that stars on the outer edges were moving just as fast as those near the center. This defied expectations, suggesting that galaxies are surrounded by massive halos of dark matter, holding them together like an invisible scaffold. But what is dark matter? Despite decades of research, its true nature remains elusive. Candidate theories, scientists propose that dark matter could consist of exotic particles such as WIMPs, weakly interacting massive particles, would interact only weakly with ordinary matter, making them incredibly difficult to detect. Search for clues. Around the world, experiments are underway to detect dark matter, from deep underground labs shielded from cosmic rays to particle accelerators attempting to create dark matter particles. For now, dark matter remains a shadow, an invisible thread weaving through the cosmos. It is the skeleton upon which galaxies are built, the silent architect of the large-scale structure of the universe. Dark energy, the force driving the universe apart. If dark matter is the unseen glue holding the universe together, dark energy is its opposite, a mysterious force driving the universe apart. In the 1990s, two independent teams of astronomers made a shocking discovery. Observing distant supernovae, they found that the universe's expansion was not slowing down as expected, but accelerating. This unexpected acceleration suggested the presence of an unknown force counteracting gravity, a force now called dark energy. Dark energy is thought to make up roughly 68% of the universe, yet its nature is even more mysterious than dark matter. The cosmological constant 1 explanation is that dark energy is a property of space itself, described by Einstein's cosmological constant. As space expands, more dark energy is created, driving further expansion in a self-reinforcing cycle. Quintessence. Another theory suggests that dark energy is a dynamic field, changing over time and space. This idea, known as quintessence, raises the possibility that the fate of the universe depends on the behavior of this mysterious force. Dark energy's effects are subtle but profound. Over billions of years, it will shape the ultimate fate of the cosmos, determining whether it expands forever, tears itself apart, or collapses into a singularity. The Cosmic Tug-of-War. The interplay between dark matter and dark energy is like a cosmic tug-of-war. Dark matter's role: it pulls galaxies together, creating the cosmic web, a vast network of filaments and clusters stretching across the universe. Without dark matter, galaxies would not have formed, and the universe would be a far emptier place. Dark energy's role: it pushes galaxies apart, stretching the fabric of space-time and driving the universe toward an uncertain future. This delicate balance defines the structure and evolution of the cosmos. Yet, as dark energy's influence grows, it is slowly overpowering the pull of dark matter. Galaxies are drifting further apart, and over billions of years, the universe may become a cold, empty expanse where stars and galaxies can no longer form. The missing 95 perfume. What are we missing? For all our technological advances, dark matter and dark energy remain frustratingly elusive. Why can't we detect them directly? Are we missing something fundamental about the nature of the universe? Some physicists suggest that dark matter and dark energy may not exist as separate entities at all. Instead, they may be symptoms of a deeper problem, a sign that our understanding of gravity or the laws of physics is incomplete. But you better than Galileo just to help us understand our own ways. Einstein's theory of general relativity, so successful in describing the cosmos, need revision on the largest scales. Others wonder if we are simply looking in the wrong place, using tools and methods that cannot detect the true nature of these forces. If dark matter and dark energy exist in forms we cannot yet imagine, what new physics will we need to uncover them? The future of exploration, the search for dark matter and dark energy continues, driving some of the most ambitious scientific projects in history. Particle detectors, deep underground labs, such as the Large Underground Xenon (LUX) experiment, are designed to detect dark matter particles passing through Earth. Robert Hale. Next-generation telescopes, Space observatories like the Euclid mission and the Nancy Grace Roman Space Telescope aim to map the effects of dark energy on the universe's expansion, theoretical breakthroughs. Physicists are developing new models and theories, from modified gravity to quantum field theories, to explain these invisible forces. Every discovery brings us closer to understanding the missing 95% of the universe. And yet, every new insight raises more questions, reminding us of the boundless complexity of the cosmos. The beauty of the invisible. Dark matter and dark energy are mysteries that challenge our understanding of reality itself. They are invisible, untouchable, and unknowable, yet they shape everything we see and experience. These forces remind us that the universe is not just a place of light and beauty, but also a realm of hidden wonders. They invite us to look beyond what is visible, to explore the unknown, and to embrace the mystery at the heart of existence. Though we cannot see them, dark matter and dark energy shape our universe in ways we are only beginning to understand. They are the silent architects of creation, the unseen forces that remind us of the infinite beauty and complexity of the cosmos. Black holes, the universe's most extreme phenomena. Few mysteries of the universe capture the imagination like black holes. They are the ultimate paradox. Regions of space where the known laws of physics cease to function. Born from the collapse of massive stars, black holes are cosmic enigmas, defy our understanding and unsure of the absence of science. What lies beyond their event horizons? What happens to the matter and energy consumed by them? And could black holes hold the answers to some of the universe's greatest mysteries? To explore black holes is to journey to the very edge of reality, into a realm where the unimaginable becomes possible. What are black holes? Black holes are regions of space where gravity is so intense that nothing, not even light, can escape. At their core lies a singularity, a point of infinite density where space and time are crushed into oblivion. Surrounding this singularity is the event horizon, the boundary beyond which nothing can return. Black holes come in many sizes, from stellar mass black holes formed by the deaths of massive stars, to supermassive black holes lurking at the centers of galaxies. These cosmic titans, millions or even billions of times the mass of the Sun, drive the dynamics of entire galaxies, pulling stars and matter into their orbit. Yet, for all we know about black holes, they remain deeply mysterious. The singularity, where physics breaks down. At the heart of every black hole lies a singularity, a point where gravity becomes infinite and the known laws of physics collapse. Here, Einstein's theory of general relativity, which describes gravity, is stretched beyond its limits. What happens at the singularity? Does it truly represent a point of infinite density? Or is it a sign that our understanding of the universe is incomplete? Many physicists believe that a theory of quantum gravity, one that unites relativity and quantum mechanics, will be needed to answer this question. Some theories propose that singularities may not exist in the way we imagine. Instead, they could be replaced by exotic structures, such as quantum loops or fuzzballs, where the fabric of space-time itself becomes unstable. Yet, without the ability to directly observe a singularity, these ideas remain speculative. The singularity is a reminder of how much we still have to learn, and of the profound mysteries that lie at the heart of black holes. The event horizon. The point of no return. The event horizon is perhaps the most iconic feature of a black hole. It is the boundary where escape becomes impossible, the edge of the cosmic abyss. To an outside observer, an object falling toward a black hole would appear to slow down as it approaches the event horizon, its light becoming increasingly redshifted until it fades from view. But for the object itself, time continues as normal, carrying it inexorably into the black hole's depths. This strange behavior is a result of the extreme warping of space-time near the event horizon. Time, gravity, and light all behave in ways that defy our everyday experience. It is a region where the familiar rules of reality give way to something far more alien. These researchers. Hawking radiation. Do black holes die? Nick Liftenhusen. Do black holes die? For many years, black holes were thought to be eternal, consuming matter and growing endlessly. But in 1974, physicist Stephen Hawking made a groundbreaking discovery. Black holes can emit radiation. Hawking radiation arises from the strange quantum effects that occur near the event horizon. As virtual particles are created and annihilated in pairs, one particle can fall into the black hole, while the other escapes, carrying energy away. Over immense spans of time, this process causes the black hole to lose mass and shrink. Eventually, a black hole could evaporate completely, leaving behind only faint traces of its existence. But this idea raises profound questions. If a black hole evaporates, what happens to the information contained within it? Is it lost forever, violating the laws of quantum mechanics? Or is it somehow preserved, encoded in the radiation that escapes? The information paradox is one of the greatest unsolved mysteries in physics, challenging our understanding of both black holes and the fundamental nature of reality. Black hole, mergers, and gravitational waves. In 2015, scientists made a monumental discovery: the detection of gravitational waves, ripples in the fabric of space-time caused by the collision of massive objects. The first detected waves came from the merger of two black holes, each dozens of times the mass of the Sun. As they spiraled closer, they released enormous amounts of energy, distorting space-time and sending waves across the cosmos. Gravitational wave astronomy has opened a new window into the universe, allowing us to listen to events that were previously invisible. Through these waves, we can study black holes in unprecedented detail, uncovering their masses, spins, and the nature of their collisions. Yet, even as we learn more about these powerful events, questions remain. What happens when supermassive black holes collide? Could such mergers produce new, exotic phenomena, such as wormholes or even entirely new universes? Pochettino, wormholes, theoretical gateways through space-time. Black holes are often linked to the idea of wormholes, hypothetical tunnels through space-time that could connect distant regions of the universe, or even different universes entirely. First proposed by Einstein and physicist Nathan Rosen in 1935, wormholes are solutions to the equations of general relativity. They suggest that space-time could fold in on itself, creating shortcuts across vast cosmic distances. But wormholes, if they exist, would be highly unstable. To remain open, they would require exotic matter with negative energy, a substance that has never been observed. Presumably, it would have to be monstrous and cryptic to warrant words like. Despite these challenges, the idea of wormholes continues to inspire both scientists and storytellers, offering tantalizing possibilities for interstellar travel and even time travel. Could black holes be natural gateways to other parts of the cosmos? Or are they the ultimate dead ends? You've examined the system for dozens of wormholes, told Chris. Have you ever noticed an exceptional one? The role of black holes in the universe. Black holes are not just destructive forces. They are also creators, shaping the evolution of galaxies and driving the dynamics of the universe. Supermassive black holes. These cosmic giants anchor galaxies, influencing the motion of stars and the flow of matter. Their powerful jets can regulate star formation, creating a delicate balance in galactic ecosystems. Primordial black holes. Some theories suggest that tiny black holes formed in the early universe, providing seeds for the growth of larger structures. Could these primordial black holes also account for dark matter? Black holes are both the engines of creation and the harbingers of destruction, playing a central role in the cosmic drama. Edwina, the mystery of black holes. Black holes are among the universe's most enigmatic phenomena. They challenge our understanding of physics, test the limits of our theories, and inspire questions that reach to the heart of existence. What lies beyond the event horizon? Is information truly lost in a black hole, or is it preserved in ways we cannot yet imagine? And could black holes hold the key to unlocking the deeper mysteries of the universe, from quantum gravity to the nature of space-time itself? As we study black holes, we are reminded of the profound beauty of the unknown. These cosmic enigmas invite us to explore the edges of reality, to push the boundaries of human knowledge, and to embrace the wonder of the cosmos. Black holes are not the end. They are the beginning of questions that challenge our imagination and inspire us to reach for the stars. The Fermi paradox. Where is everyone? The universe is vast beyond comprehension. In the Milky Way galaxy alone, there are an estimated 100 billion stars, many of which are orbited by planets. Beyond our galaxy lie trillions more, each brimming with possibilities. With such staggering numbers, the odds seem overwhelming that intelligent life must exist somewhere out there. And yet, the universe is silent. We have heard no signals, seen no evidence, and encountered no visitors. For all our searching, humanity appears to be alone. This contradiction between the high probability of extraterrestrial life and the complete lack of evidence for it is known as the Fermi paradox. It is one of the most profound mysteries of the cosmos, challenging our understanding of life, intelligence, and the universe itself. The vastness of the universe. To grasp the scale of the Fermi paradox, we must first consider the vastness of the universe. Astronomers estimate that the observable universe contains approximately 2 trillion galaxies, each hosting billions or trillions of stars. Around these stars orbit countless planets, many of which reside in the habitable zone, the region where conditions might support liquid water and, potentially, life. The sheer abundance of stars and planets makes it almost inconceivable that Earth is the only world to host intelligent life. And yet, despite this overwhelming probability, we have found no sign of it. If intelligent civilizations exist, or have ever existed, why haven't we detected their presence? Why hasn't the galaxy been colonized by an advanced species? And why does the night sky remain so quiet? These questions lie at the heart of the Fermi paradox. The origins of the paradox. The Fermi paradox is named after physicist Enrico Fermi, who posed the question in 1950 during a casual conversation with colleagues. Reflecting on the scale of the galaxy and the potential for advanced civilizations, Fermi asked, "Where is everybody?" At its core, the paradox is a simple observation. If intelligent life is common in the universe, it should be detectable. Civilizations that develop advanced technology could spread across the galaxy, colonizing planets and leaving behind unmistakable signs of their existence. Yet, despite decades of searching, through radio telescopes, planetary exploration, and the study of exoplanets, we have found nothing. Possible solutions to the Fermi paradox. Scientists and philosophers have proposed countless solutions to the Fermi paradox, ranging from the optimistic to the unsettling. 1. We are rare. Note, the rare Earth hypothesis suggests that intelligent life is extraordinarily rare, requiring a unique combination of conditions. Earth may be a cosmic anomaly, a planet with just the right ingredients for life to evolve and thrive. Life may exist elsewhere in the universe, but intelligence might be exceedingly rare, arising only under very specific circumstances. 2. The Great Filter. The Great Filter hypothesis proposes that there is a barrier or series of barriers that prevents life from reaching the stage of interstellar communication or colonization. This filter could exist at any point in a civilization's development. It might be the origin of life itself, the transition to multicellular organisms, or the leap to advanced technology. If the great filter lies in our future, it suggests that civilizations inevitably self-destruct before achieving widespread expansion through war, environmental collapse, or other catastrophic events. They're already here. Some argue that extraterrestrial civilizations may already be observing us but choose not to interfere, a concept known as the zoo hypothesis. In this scenario, advanced beings regard humanity as an experiment, a species to be studied from a distance without direct contact. 2. The universe is dangerous. The dark forest hypothesis, inspired by the work of author Liu Cixin, posits that advanced civilizations avoid broadcasting their presence out of fear. In a hostile universe where resources are limited, any civilization that reveals itself risks being targeted by more advanced species. As a result, intelligent life may remain deliberately silent. 3. We're not listening properly. It's possible that extraterrestrial civilizations are communicating in ways we don't yet understand. They may use technologies far beyond our current capabilities, or their signals could exist outside the electromagnetic spectrum we are monitoring. Alternatively, they may simply have no interest in communicating with us, viewing humanity as too primitive to warrant contact, searching for life. Despite the silence, the search for extraterrestrial life continues. Organizations like SETI, the Search for Extraterrestrial Intelligence, scan the skies for signals, listening for any sign of communication from other worlds. At the same time, missions like the James Webb Space Telescope and upcoming observatories are studying exoplanets in unprecedented detail. By analyzing the atmospheres of distant worlds, scientists hope to detect biosignatures, chemical markers that indicate the presence of life. These efforts represent humanity's enduring curiosity and determination. Even in the face of uncertainty, we continue to reach for the stars, driven by the belief that we are not alone. The implications of silence, more than as a force of silence we remain, can only be something for one of us. And how silence we remain can only speak for the universe's potential. If we are not alone, it underscores the preciousness of life on Earth. It means that every moment, every species, and every human achievement is unique in the cosmos. If we are not alone, it raises profound questions about our place in the universe. How would contact with another civilization reshape our understanding of ourselves? Would it unite humanity or divide us further? And if the great filter lies ahead of us, it serves as a stark warning, a reminder of the fragility of civilization and the importance of ensuring our survival. The wonder of the question. The Fermi paradox is not just a question of science, it is a question of identity. It challenges us to think about who we are, what we value, and what it means to be human. In the silence of the universe, there is both mystery and beauty. It reminds us of the fragility of our existence, the importance of curiosity, and the boundless potential of discovery. As we gaze at the stars, we are reminded that the search for life is ultimately a search for connection, for understanding our place in a cosmos that is both infinitely vast and deeply mysterious. Perhaps the silence of the universe is not an absence, but an invitation, an opportunity to explore, to wonder, and to dream of what lies beyond. The nature of consciousness, a cosmic puzzle. Amidst the vast expanse of the universe, there is one mystery that feels deeply personal: consciousness. Unlike the distant galaxies or the invisible forces of dark matter, consciousness is something we all experience. It is the lens through which we view reality, the essence of what it means to be alive. But what is consciousness? Is it merely the product of neurons firing in the brain? Or is it something more fundamental, woven into the fabric of the universe itself? Despite centuries of study, consciousness remains one of the most profound and unsolved mysteries in science and philosophy. To explore consciousness is to journey inward, to ask questions about the nature of existence, perception, and reality itself. What is consciousness? Consciousness is often described as the state of being aware, of experiencing thoughts, emotions, and sensations. It is what allows us to perceive the world, to reflect on our place within it, and to ponder questions about the universe. Yet for all its familiarity, consciousness defies easy explanation. How does the brain, a physical organ made of atoms and molecules, give rise to the rich, subjective experience of being? This is the hard problem of consciousness, a challenge that has puzzled scientists and philosophers for centuries. The mind-body problem. At its core, the study of consciousness grapples with the relationship between the physical and the mental. Is the mind purely a product of the brain, or is it something distinct? Qualia. Consciousness is filled with qualia, the raw subjective experiences of the world. The taste of chocolate, the color red, the feeling of joy. These are deeply personal and cannot be measured or quantified. What gives rise to these experiences? Theories of consciousness. Over the years, countless theories have emerged to explain consciousness, each offering a different perspective on this enigmatic phenomenon. Materialist theories propose that consciousness arises entirely from the brain's physical processes, the firing of neurons, the release of chemicals, and the interaction of networks create the subjective experience we call mind. While this view aligns with much of modern neuroscience, it struggles to explain how physical processes translate into subjective awareness. Dualism, the belief in various realms, a concept rooted in the philosophy of René Descartes, suggests that the mind and body are separate entities. The brain may process information, but consciousness exists in a non-physical realm. This perspective raises questions about how the mind interacts with the body and whether consciousness can exist independently of the brain. Integrated information theory, IIT, posits that consciousness arises from the integration of information. The more interconnected and unified a system's information, the greater its level of consciousness. This theory suggests that consciousness is not limited to humans or animals. It could exist in varying degrees in all systems capable of processing information, from simple organisms to artificial intelligence. Some sources point to this structure as simple cells being built out of self-destructive material. Inscribed intact in the citation is quantum consciousness. Some scientists, such as Roger Penrose, propose that consciousness may arise from quantum processes occurring within the brain. In this view, the brain functions as a quantum system, capable of harnessing the strange and unpredictable behaviors of particles to produce consciousness. While intriguing, quantum theories of consciousness remain highly speculative and controversial. In panpsychism takes a radical approach, suggesting that consciousness is a fundamental property of the universe, like mass or energy. In this view, even the smallest particles possess a form of awareness. Though it may seem counterintuitive, panpsychism offers an elegant solution to the hard problem of consciousness. Instead of arising from complex systems, consciousness is intrinsic to all matter. Consciousness and time. One of the most intriguing aspects of consciousness is its relationship with time. We experience time as a continuous flow, moving steadily from the past to future. But is this perception real, or is it a construct of our minds? Neuroscientists have found that the brain processes events in discrete moments, assembling them into a seamless narrative. Consciousness also shapes our perception of time's passage. In moments of joy, time seems to fly. In moments of sorrow, it drags endlessly. This subjective experience reveals the deeply personal nature of time, tied not to the ticking of a clock, but to the rhythms of our thoughts and emotions. Could consciousness itself influence the flow of time? Some theorists suggest that our awareness creates the illusion of linear time, transforming a timeless reality into the familiar structure of past, present, and future. The cosmic implications of consciousness. Consciousness is not just a mystery of biology, it is a question of cosmology. What if our awareness is not confined to our brains, but is connected to the universe in ways we do not yet understand? Some physicists have speculated that consciousness could play a role in shaping reality itself. The famous observer effect in quantum mechanics suggests that the act of observation influences the behavior of particles. Could this phenomenon hint at a deeper relationship between consciousness and the fabric of the universe? Others wonder if consciousness might be a bridge between the physical and the metaphysical, a glimpse into dimensions beyond our perception. If panpsychism is correct, then consciousness may be as fundamental as gravity, present in everything from subatomic particles to the largest galaxies. Consciousness beyond Earth. If consciousness is a universal phenomenon, could it exist elsewhere in the cosmos? Life on Earth has evolved an extraordinary diversity of forms, each with its own way of perceiving the world. From the sonar of bats to the polarized vision of insects, consciousness expresses itself in countless ways. Could alien life, if it exists, have developed entirely different forms of awareness? Some scientists suggest that we may already share the universe with conscious beings, but their modes of thought and communication are so different from ours that we cannot recognize them. Others propose that consciousness may not require biological life at all. It could arise in artificial intelligence, machine networks, or even in the fabric of space-time itself. Oh, the mystery of self-awareness. The truth about how great we are. One of the defining features of human consciousness is self-awareness, the ability to think about ourselves, to reflect on our thoughts, and to question our place in the universe. Self-awareness is both a gift and a burden. It allows us to create art, science, and philosophy, but it also confronts us with the inevitability of death and the fragility of existence. Why has self-awareness evolved? Does it serve a purpose, or is it an accident of evolution? And could other species or even machines develop this profound level of consciousness? The beauty of the mystery. The mystery of consciousness is not just a scientific puzzle. It is a source of wonder. It reminds us that for all our knowledge, there are still questions that lie beyond our grasp. Consciousness is the bridge between the universe and the self, the lens through which we experience reality. It connects us to the stars, to each other, and to the infinite mysteries of existence. As we ponder consciousness, we are reminded of the beauty of not knowing, of the journey to understand, and of the profound connection between the cosmos and the mind. Consciousness is not just a question of what we are. It is a question of who we are, and of the infinite possibilities that lie within and beyond us. The quantum world, reality at the smallest scales. At the smallest scales of reality, the universe behaves in ways that defy our intuition. In the quantum world, particles can exist in multiple states at once, communicate instantaneously across vast distances, and behave as both particles and waves. This strange and beautiful realm lies at the heart of physics, governing the building blocks of matter and energy. Yet for all its power to explain the workings of the universe, quantum mechanics leaves us with profound questions about the nature of reality itself. What is a particle? What does it mean to observe something? And could the mysteries of the quantum world hold the key to understanding the cosmos? The dual nature of particles, waves and particles at once. One of the fundamental discoveries of quantum mechanics is that particles, such as electrons and photons, exhibit a dual nature. They can behave as waves, spreading out across space, or as particles, existing in specific locations. This wave-particle duality is best demonstrated in the famous double-slit experiment. When particles are fired through two narrow slits, they create an interference pattern on a screen, as if they were waves passing through both slits simultaneously. But when the particles are observed, the interference pattern disappears. They behave as particles, passing through one slit or the other. This experiment raises a profound question. How does the act of observation change the behavior of particles? What does it mean for a particle to decide how to behave? Quantum superposition, being in two places at once. In the quantum world, particles do not exist in definite states until they are observed. Instead, they exist in a superposition, a combination of all possible states. For example, an electron in an atom does not orbit the nucleus like a planet around the sun. Instead, it exists as a probability cloud, simultaneously in many locations. Only when we measure its position does it collapse into a single state. This idea, while counterintuitive, is supported by countless experiments. It suggests that reality at the quantum level is not fixed but fluid, shaped by probabilities rather than certainties. Quantum entanglement, spooky action at a distance. Quantum entanglement is one of the most mysterious and intriguing phenomena in physics. When two particles become entangled, their states are linked no matter how far apart they are. If one particle is measured and its state is determined, the state of the other particle is instantly known, even if they are light years apart. Albert Einstein famously referred to this phenomenon as spooky action at a distance, as it seemed to defy the laws of relativity, which state that no information can travel faster than the speed of light. Yet experiments have repeatedly confirmed the reality of entanglement. It suggests that particles are not truly separate, but part of a deeper, interconnected reality. Could this interconnectedness extend beyond particles, linking all matter and energy in the universe? And if so, what does it mean for our understanding of space, time, and causality? The measurement problem. Does observation create reality? One of the central mysteries of quantum mechanics is the measurement problem. At the quantum level, particles exist in superpositions of multiple states, but when we observe them, they collapse into a single state. This raises a profound question. Does the act of observation create reality? Is the universe fundamentally indeterminate until it is measured? The thought experiment known as Schrödinger's cat illustrates this dilemma. Imagine a cat in a sealed box with a quantum particle that has a 50% chance of triggering a deadly event. Until the box is opened, the cat is both alive and dead, a superposition of states. Only when we look does the cat's fate become definite. This paradox highlights the strange interplay between the observer and the observed. Could consciousness itself play a role in shaping the quantum world? The quest for quantum gravity, reconciling the small and the large. While quantum mechanics describes the universe at the smallest scales, general relativity governs the largest, planets, stars, and galaxies. These two theories are incredibly successful in their domains, yet they are fundamentally incompatible. The challenge of uniting them into a single framework, known as quantum gravity, is one of the greatest unsolved problems in physics. String theory. One approach to quantum gravity is string theory, which proposes that particles are not points but tiny vibrating strings. These strings exist in multiple dimensions, offering a way to reconcile quantum mechanics and relativity. Loop quantum gravity. Another theory suggests that space-time itself is made up of discrete quantum units, like the pixels of a digital image. Studying the behavior of quantum particles near black holes, where gravity is extreme, could provide insights into this elusive theory. The multiverse, a quantum reality? Quantum mechanics has given rise to the idea of the multiverse, a vast collection of parallel universes, each with its own unique properties. The many worlds interpretation of quantum mechanics suggests that every possible outcome of a quantum event actually occurs, creating a new universe for each possibility. In this view, there are infinite versions of reality, branching out from every decision, every particle interaction, and every moment in time. While the multiverse remains speculative, it offers a tantalizing glimpse into the possibilities of quantum reality. Could our universe be just one of countless others? And if so, what lies beyond the boundaries of what we can observe? Quantum mysteries and the nature of reality. The quantum world challenges our understanding of reality at its most fundamental level. It reveals a universe that is not fixed, but fluid, where particles are waves, where observation shapes existence, and where everything is connected in ways we cannot yet comprehend. These mysteries are not just puzzles for physicists, they are invitations to rethink our place in the cosmos. They remind us that reality is far stranger and far more beautiful than we can imagine. The quantum world is a doorway to the unknown, a glimpse into the infinite possibilities that lie within the smallest scales of existence. The arrow of time. Why does time flow? Time is the great constant of our existence. It moves forward, pulling us through the moments of our lives, from the fleeting present to the ever-expanding past. Yet, as fundamental as time feels, it holds a mystery at its core. Why does it flow in one direction? Physicists call this the arrow of time, the idea that time has a preferred direction, always moving forward. But why should time have an arrow at all if the laws of physics are reversible, able to run forward or backward? Why do we experience time as a one-way journey? Exploring the arrow of time takes us to the heart of some of the deepest questions in physics, philosophy, and cosmology. It is a journey into the nature of entropy, the origins of the universe, and the fundamental structure of reality itself. The flow of time, a human perspective. For humans, the flow of time is one of the most profound aspects of existence. It shapes our memories, our plans, and our very sense of self. Yet, our perception of time is deeply subjective. In moments of joy, time seems to race forward. In moments of sorrow, it slows to a crawl. Our minds construct a narrative of past, present, and future, giving us the illusion of time's steady flow. But does time itself flow, or is this flow an artifact of human consciousness? Could it be that time, like space, simply exists, with no inherent direction? The arrow of time and entropy. The arrow of time is most famously linked to the second law of thermodynamics, which states that entropy, a measure of disorder, always increases in a closed system. Imagine breaking an egg into a bowl. The yolk and white mix into a chaotic state, but you never see the process reverse itself. Once mixed, the egg cannot return to its original form. This progression toward disorder gives time its direction. In the early universe, shortly after the Big Bang, the cosmos was in an extraordinarily low entropy state, a state of remarkable order. Over billions of years, as stars formed, galaxies collided, and systems evolved, entropy increased. The arrow of time, it seems, is a consequence of this journey from order to disorder. But why did the universe start in such a low entropy state? What set the arrow of time in motion? Time and the equations of physics. The mystery deepens when we examine the fundamental laws of physics. Most of these laws, whether describing the motion of planets or the behavior of subatomic particles, are time-symmetric. They work just as well in reverse as they do forward. If the laws of physics do not dictate a preferred direction, why do we experience time as moving forward? What distinguishes the past from the future? This discrepancy has puzzled scientists and philosophers for centuries. Some propose that the arrow of time arises not from the laws of physics themselves, but from the conditions of the universe at its beginning. The beginning of time, a cosmic perspective. The arrow of time is intimately tied to the origins of the universe. At the moment of the Big Bang, the cosmos was in a state of extraordinary simplicity and order. This initial condition set the stage for the increase in entropy that drives the arrow of time. But why did the universe begin in such a state? Was it a random fluctuation? Or does it hint at deeper laws governing the cosmos? Some physicists suggest that our universe is just one of many, part of a multiverse, where different regions have different arrows of time. In this view, the direction of time may be a local phenomenon, shaped by the conditions of our particular universe. The end of time, the fate of the universe. As entropy increases, the arrow of time points inevitably toward the future. But what lies at the end of time's journey? One possibility is the heat death of the universe, a state of maximum entropy where all energy is evenly distributed and no work can be done. Stars will burn out, galaxies will drift apart, and the cosmos will become a cold, dark expanse. Alternatively, if the universe's expansion reverses, it could collapse into a big crunch, resetting the arrow of time. In some theories, this cycle of expansion and contraction could repeat endlessly, giving rise to a universe where time itself is cyclical. These scenarios challenge our understanding of time's ultimate nature. Does time have an end, or does it extend infinitely? And if time ceases to exist, what comes after? The psychological arrow of time. While entropy governs the physical arrow of time, our experience of time is shaped by memory and perception. We remember the past but not the future. We anticipate what is to come, but cannot relive what has been. Why is this the case? Neuroscientists suggest that memory creates a psychological arrow of time, anchoring us to the flow of events. Yet this raises deeper questions. If the brain constructs our sense of time, is the flow of events illusion? Some philosophers argue that time is not a fundamental property of the universe, but a construct of human consciousness. In this view, the past, present, and future exist simultaneously, like the frames of a film reel, with our awareness moving through them. Time and extreme environment. In the universe's most extreme environments, the arrow of time becomes even more mysterious. Near a black hole, where gravity warps space-time, time slows dramatically. For an observer near the event horizon, moments could stretch into eternity, while for distant observers, time flows normally. These distortions reveal that time is not an absolute, fixed quantity. It is fluid, shaped by gravity and motion. In such environments, the arrow of time becomes a complex relative phenomenon. The beauty of the arrow of time. The arrow of time is both a scientific puzzle and a source of wonder. It connects us to the cosmos, reminding us of the vast, intricate processes that shape the universe. It is the reason why stars burn, why galaxies evolve, and why we experience life as a series of moments. It is the thread that links the past to the future, weaving the story of existence. As we reflect on the arrow of time, we are reminded of the beauty of questions that defy simple answers. Time is not just a measure of moments. It is the rhythm of the universe, a mystery that invites us to explore, to wonder, and to dream. Time flows, and with it, the universe unfolds. In the journey of time, we find the essence of existence, the beauty of change, the mystery of moments, and the infinite possibilities of the future. Life and the conditions for existence. Life is one of the rarest and most extraordinary phenomena in the universe. It is the spark that transforms matter into something more, something capable of growth, reproduction, and awareness. Here on Earth, life is everywhere. From the depths of the oceans to the peaks of mountains, from microscopic bacteria to vast ecosystems, it thrives in forms as diverse as the stars themselves. Yet as abundant as life is on our planet, we have yet to find it elsewhere. What makes life possible? What are the conditions that allow it to emerge, evolve, and flourish? And could these conditions exist beyond Earth in the vastness of the cosmos? To explore the mystery of life is to ask questions about origins, resilience, and the nature of existence itself. The origins of life, a cosmic puzzle. The story of life begins billions of years ago, in the primordial soup of the young Earth. Here, a remarkable transformation occurred. Simple molecules combined to form complex structures, giving rise to the first living cells. But how did this happen? The origin of life remains one of the greatest unsolved mysteries in science: abiogenesis. Most scientists believe that life arose through a process called abiogenesis, where non-living complex compounds formed self-replicating molecules. These molecules eventually evolved into more complex systems, capable of metabolism and reproduction. The role of RNA, one leading theory suggests that RNA, a molecule similar to DNA, played a key role in the emergence of life. RNA can store genetic information and catalyze chemical reactions, making it a possible precursor to life as we know it. Distinction. A renal flax contains a high value for humans, all known to metabolize life as we know it. The role of the environment. The early Earth provided the raw materials for life: water, energy from the sun, and a rich array of organic compounds. But was this combination unique, or could it occur elsewhere in the universe? Author Stuart Mitchell. The mystery of life's origins challenges us to think beyond Earth, to consider the possibility that the conditions for life may exist on other planets, moons, or even in interstellar space. Our life is comprised of the controversial universal truths of experience and philosophy. The requirements for life. What does it take? While life on Earth is incredibly diverse, it shares certain fundamental requirements. These include liquid water. Water is often called the universal solvent because it facilitates the chemical reactions necessary for life. On Earth, water is essential for everything from the simplest bacteria to the most complex ecosystems. This is why scientists searching for extraterrestrial life often focused on planets and moons where liquid water might exist. Energy. Life requires energy to grow and reproduce. On Earth, this energy comes primarily from the sun, but some organisms thrive on chemical energy, such as those found near deep-sea hydrothermal vents. Organic molecules, carbon-based molecules, such as amino acids and nucleotides, form the building blocks of life. These molecules provide the structure and function of cells, DNA, and proteins. Stability. Life needs a stable environment to evolve and flourish. Planets or moons with long-lasting atmospheres, magnetic fields, and temperate climates are considered prime candidates for hosting life. Could these conditions exist elsewhere in the universe? With billions of stars and trillions of planets, it seems likely. But life may also take forms we cannot yet imagine, thriving in environments vastly different from our own. Life beyond Earth. The search for biosignatures. The search for extraterrestrial life is one of humanity's most ambitious endeavors. Scientists are exploring a variety of environments, both within our solar system and beyond, for signs of life. Mars, the red planet, once had flowing rivers and lakes, and may still harbor microbial life beneath its surface. Missions like the Perseverance rover are searching for biosignatures. Missions like the Perseverance rover are searching for biosignatures, chemical evidence of past or present life. Europa and Enceladus, these icy moons of Jupiter and Saturn, are thought to have subsurface oceans, protected by thick layers of ice. Hydrothermal vents on their ocean floors could provide the energy needed for life. Exoplanets. With the discovery of thousands of planets orbiting distant stars, the search for habitable worlds has expanded dramatically. Instruments like the James Webb Space Telescope are analyzing the atmospheres of exoplanets for signs of water, oxygen, and other markers of life. The discovery of extraterrestrial life, even in its simplest form, would revolutionize our understanding of the universe. It would show that life is not unique to Earth, but a fundamental aspect of the cosmos, the resilience of life. One of the most astonishing discoveries in biology is the resilience of life. On Earth, organisms known as extremophiles thrive in environments once thought to be uninhabitable. In the deep ocean, where sunlight never reaches, bacteria live off the chemicals released by hydrothermal vents. In Antarctica, microbes survive in sub-zero temperatures, encased in ice for thousands of years. In acidic hot springs and radioactive wastes, life finds a way to adapt and endure. These discoveries expand our understanding of where life can exist. If life can survive in such extreme conditions on Earth, could it not also exist in the icy oceans of Europa or the methane lakes of Titan? The question of panspermia. Could life on Earth have come from somewhere else? The theory of panspermia suggests that life, or its building blocks, may have originated in space, traveling on comets or asteroids to seed planets like Earth. Organic molecules have been found on meteorites and in interstellar clouds, suggesting that the ingredients for life are widespread in the universe. Some experiments have shown that certain microbes can survive the harsh conditions of space, lending credibility to the idea that life could travel between planets or even star systems. If panspermia is true, it implies that life may not have a single point of origin, but is instead a cosmic phenomenon, spreading across the universe like seeds on the wind. The uniqueness of Earth. While the search for life beyond Earth is filled with hope, it also reminds us of the uniqueness of our planet. Earth is a rare oasis, a world where all the conditions for life have come together in perfect harmony. The balance of Earth's atmosphere, the presence of liquid water, and the stability of its orbit around the Sun create a delicate environment where life can thrive. This balance is not guaranteed, and it serves as a reminder of the fragility of our home. If life is rare, then every living thing on Earth becomes even more precious, a testament to the incredible journey of evolution and the miracle of existence. The mystery of life's future. The story of life is still unfolding. On Earth, it has evolved from single-celled organisms to complex ecosystems, from primitive animals to self-aware beings capable of questioning their place in the cosmos. What comes next? Will humanity venture beyond Earth, carrying life to other planets and moons? Will we one day discover other forms of life, reshaping our understanding of biology and the universe? The future of life is a mystery, filled with possibilities as vast as the cosmos itself. The wonder of life. Life is the universe made aware of itself. It is the spark that transforms matter into meaning, the force that connects us to the cosmos and to each other. As we explore the conditions for existence, we are reminded of the beauty and fragility of life. Whether we find it elsewhere or only here, it is a gift, a reminder of the infinite possibilities that arise when matter and energy come together in just the right way. Life is the greatest mystery of all. It is the thread that weaves through the cosmos, reminding us that even in the vastness of the universe, there is meaning, connection, and wonder. The ultimate fate of the universe. The universe is a story, a vast unfolding narrative written across billions of years, from its fiery birth in the Big Bang to the formation of stars and galaxies. It has been a tale of creation, transformation, and evolution. But every story has an ending, and the universe is no exception. What will become of the cosmos? Will it expand forever, fade into darkness, or collapse into itself? The ultimate fate of the universe is one of the most profound and unsettling questions in cosmology, a mystery that challenges our understanding of time, space, and existence itself. The expanding universe. In the 1920s, astronomer Edwin Hubble made a groundbreaking discovery. The universe is expanding. Observing distant galaxies, he found that they were moving away from us. Their light shifted to longer, redder wavelengths, a phenomenon known as redshift. This discovery transformed our understanding of the cosmos, It revealed that space itself is stretching, carrying galaxies with it, like dots on the surface of an inflating balloon. But this expansion raises profound questions. Will it continue forever? Or will it one day reverse? And what does it mean for the fate of the universe? The role of dark energy. In the 1990s, scientists made a startling discovery. The expansion of the universe is not slowing down, as previously thought. It is accelerating. This acceleration is driven by a mysterious force called dark energy, which makes up roughly 68% of the universe. Dark energy is the dominant force shaping the cosmos today, and its nature remains one of the greatest unsolved mysteries in science, the cosmological constant. Some physicists believe that dark energy is a constant property of space, an inherent feature that grows as space expands. Dynamic dark energy. Others propose that dark energy could be a changing field, evolving over time and influencing the universe in unpredictable ways. The behavior of dark energy will determine the ultimate fate of the universe. If its effects remain constant, the cosmos will continue to expand indefinitely. But if it grows stronger or weaker, it could lead to entirely different outcomes. The possible fates of the universe, the Big Freeze. In this scenario, the universe continues to expand forever, with galaxies moving further and further apart. Over billions of years, stars will burn out, leaving behind black holes, neutron stars, and white dwarfs. As time stretches on, even black holes will evaporate through Hawking radiation, and the universe will become a cold, dark expanse, a state known as heat death, the Big Crunch. If dark energy weakens or reverses, the expansion of the universe could slow and eventually halt. Gravity would then take over, pulling galaxies back together. This would lead to a Big Crunch, where the universe collapses into a singularity, possibly triggering a new Big Bang and a cyclical model of creation and destruction. The Big Rip. If dark energy grows stronger over time, it could overpower gravity, tearing apart galaxies, stars, and even atoms. Till this catastrophic end, known as the Big Rip, would leave the universe fragmented into individual particles, scattered across an infinite void, eternal inflation. Some theories suggest that our universe is part of a multiverse, where regions of space undergo constant inflation. In this view, our universe could continue expanding forever, while new bubble universes form in distant regions, creating an eternal cycle of cosmic creation. The arrow of time and the end of the universe. The fate of the universe is intimately tied to the arrow of time. And that's part of the arrow of time. As entropy increases, the cosmos moves toward a state of maximum disorder, where no energy remains to fuel stars, planets, or life. This journey toward equilibrium is a reminder of the finite nature of all things. Yet, it also highlights the beauty of the universe's story, a tale of transformation, where each stage gives rise to new possibilities. Even in its final moments, the universe will remain a place of wonder, filled with the echoes of its past. What lies beyond the end? If the universe reaches its end, what comes next? Some theories suggest that the death of the universe may not be the end of everything. In a cyclical model, the universe could collapse and be reborn in a new Big Bang, starting the process anew. Others propose that new universes could emerge from quantum fluctuations, creating an infinite multiverse where each universe has its own unique properties. And then there is the possibility that the universe's end is truly final, a silence that stretches forever, beyond time and space. These ideas challenge our imagination and remind us of the limits of our understanding. They invite us to contemplate not just the end of the universe, but the nature of existence itself. Humanity's place in the cosmos. As we ponder the ultimate fate of the universe, we are reminded of our place within it. We are a tiny part of a vast, evolving cosmos, connected to the stars, the galaxies, and the forces that shape reality. The universe's story is our story. It is the story of atoms forged in the hearts of stars, of life emerging from the chaos of creation, and of minds capable of asking the deepest questions about existence. What role will humanity play in this cosmic narrative? Will we find a way to endure beyond Earth, carrying the spark of life to other planets and stars? Or will we remain bound to our fragile home, witnessing the universe's story as it unfolds? The wonder of the unknown. The ultimate fate of the universe is a mystery that transcends science. It is a question of beginnings and endings, of cycles and transformations, and of the infinite possibilities that lie beyond what we can see. As we reflect on the universe's future, we are reminded of its beauty and complexity. The cosmos is not just a collection of stars and galaxies. It is a place of wonder, a reminder of the interconnectedness of all things, and an invitation to explore the unknown. The universe is a story, written across the fabric of time and space. Though we may not know how it ends, its journey fills us with awe, reminding us of the infinite beauty of existence. Reflective conclusion. As we bring our journey to a close, we find ourselves in quiet reflection, standing at the edge of all we know and all we do not. The mysteries of the universe stretch before us, vast and infinite, inviting us to ponder questions that transcend time, space, and even existence itself. Through the course of this exploration, we have ventured into the heart of the cosmos, and beyond. We have contemplated the origins of the universe, the invisible forces that shape reality, the extremes of black holes, the paradox of life, the strangeness of the quantum world, and the enigmatic flow of time. Each mystery is a thread in the great cosmic tapestry, a story that connects us to the stars and to each other. Yet, for all our discoveries, these mysteries remain unsolved. And perhaps that is their greatest gift. The unknown is not a void to be feared, but a canvas upon which our curiosity, imagination, and wonder can flourish. At the beginning and the end, a cosmic symphony. Our journey began at the beginning, at the moment of the Big Bang, when time and space were born from an unimaginable explosion of energy. From that singular moment, the universe unfolded, giving rise to galaxies, stars, and planets, each a tiny piece of the puzzle. Yet, even as we trace the origins of the cosmos, we are left with profound questions. What came before the Big Bang? Was it a singular event, or part of a larger cycle? The origins of the universe remain shrouded in mystery, a reminder that some questions may forever lie beyond our reach. As we ponder the beginning, we are drawn to the end. What will become of the universe? Will it expand forever, growing colder and darker until all light fades? Will it collapse into itself, only to be reborn in a new Big Bang? Or will it follow a path we cannot yet imagine? The symphony of creation and transformation. It is a reminder that existence itself is dynamic, filled with cycles of life, death, and rebirth. The invisible forces that shape reality. Beneath the visible beauty of the cosmos lies a hidden reality, one shaped by forces we cannot see. Dark matter, the invisible skeleton of the universe, holds galaxies together, while dark energy drives them apart, accelerating the expansion of space. These forces, which make up 95% of the cosmos, remain among the greatest mysteries of modern science. What is dark matter? What is dark energy? Are they fundamental aspects of reality, or signs that our understanding of the universe is incomplete? The search for answers to these questions is a journey into the unknown, a quest to uncover the secrets of the cosmos and our place within it. Yet even as we seek to illumine the invisible, we are reminded of the beauty of what we do not know. The unseen forces of the universe are not just scientific puzzles. They are a testament to the vastness of existence, a reminder that there is always more to discover. Michael Richter, The Extremes of Existence, Black Holes and Quantum Realities. Black holes and the quantum world represent the extremes of existence, the places where our understanding of reality breaks down. Black holes, with their infinite gravity and event horizons, challenge our knowledge of space and time. They remind us that the universe is not just a place of order, but also a realm of chaos and mystery. What lies beyond the event horizon? Is information truly lost in a black hole? Or does it persist in ways we cannot yet comprehend? At the opposite scale, the quantum world reveals a universe that is fluid and interconnected, where particles exist in multiple states and communicate instantaneously across vast distances. Quantum mechanics defies our intuition, suggesting that reality at its smallest scales is not fixed, but shaped by probabilities and observation. These extremes, the largest and smallest scales of the universe, are a reminder of the profound complexity of existence. They challenge us to rethink our assumptions about reality and invite us to explore the boundaries of what is possible. Victor Pollock, Life, the Universe Made Aware. Amidst the vastness of the universe, life is one of its rarest and most extraordinary phenomena. It is the spark that transforms matter into something more, something capable of growth, creativity, and awareness. On Earth, life has flourished in astonishing diversity, adapting to environments from the depths of the oceans to the peaks of mountains. But what about beyond Earth? Could life exist on distant planets, in the icy oceans of moons, or even in forms we cannot yet imagine? The search for life is not just a scientific endeavor, it is a deeply philosophical one. It raises questions about our uniqueness, our purpose, and our connection to the cosmos. If life is found elsewhere, it would affirm that the universe is teeming with potential. If not, it would underscore the preciousness of life on Earth. A fragile oasis in an infinite void. Life is the universe made aware of itself, a reminder that amidst the cold vastness of space there is warmth, connection, and meaning. Time, the thread that connects all things. Time is the thread that weaves through all these mysteries, connecting the past, present, and future. It is the rhythm of the universe, guiding the formation of stars, the evolution of life, and the ultimate fate of the cosmos. Yet time itself remains one of the greatest enigmas. Why does it flow in one direction? Is the arrow of time a fundamental property of the universe, or a consequence of entropy? And could there be places or conditions where time behaves differently or ceases to exist altogether? As we ponder time, we are reminded of its dual nature. It is both universal and deeply personal, shaping the cosmos while grounding our human experience. It is a force of change, a measure of moments, and a mystery that transcends understanding. The beauty of the unknown. As we reflect on the mysteries we have explored, we are left with a profound sense of wonder. The universe is vast, complex, and deeply mysterious, filled with questions that may never be answered. Yet, it is this very mystery that inspires us. The unknown is not a barrier, it is an invitation. It challenges us to think, to dream, and to explore, reminding us that the journey of discovery is as important as the answers we seek. The universe is not just a collection of stars, galaxies, and particles. It is a place of infinite possibility, a reflection of our own curiosity and imagination. It can be frightening or beautiful if we let it. It can be creative if we modify it. Our final reflection. As we close this journey, let us take a moment to reflect on our place within the universe. We are a tiny part of something far greater, a vast, interconnected cosmos that has existed for billions of years and will continue to evolve long after we are gone. Yet, in our smallness, there is significance. We are the universe made conscious, capable of asking questions about its origins, its nature, and its future. We are explorers, dreamers, and storytellers, connected to the stars and to each other. The mysteries of the universe are not just questions to be solved. They are the essence of what it means to be human. They remind us that life, existence, and the cosmos itself are filled with wonder, beauty, and infinite potential. The universe is a story without end, a journey without a final destination. Its mysteries are an invitation to wonder, to dream, and to embrace the infinite beauty of the unknown. It's a strange time to be alive, because to be alive is to be alive.